Hello everyone. In this video, we will be talking about measure of central tendency. So when we are dealing with a huge amount of data, so when I'm saying a huge amount of data, so often when we are working in any organization, the data which is being given to us is basically huge amount. It's in terabytes, okay, or it can have a numerous number of rows and columns, okay. So what we see here is that all this data, all this huge amount of data is always clustering around the middle value, and this middle value is called as central tendency. This measure of central tendency is also called as measure of location, statistical averages. So in some books, instead of using the term measure of central tendency, it's being used as measure of location and statistical averages. So now there are different types of measure of central tendency. They are mean, median, and mode. So when we talk about mean, so mean is basically the uh, average of the. It can also be given as the average or average of all the observations in simple words. The formula for mean is a sum of all observations divided by the number of observations. And in mathematically, in books, you will see that it's being written as this way: mean of x is equal to summation of all the values which is present for that particular x divided by the total number of the variables which is being present. Simple example, let's say we have a sales data, monthly sales data, and it's been something around 25, 37, 88, 42, and 38. Okay. So if somebody asks you how to calculate a mean, what we can do, we can just add all of them, sum of all the observation divided by the number of observations. So number of observation here is 5. So it is going to give us 46. So 46 here is the mean. Now, next comes the median. So median is basically the middle value in a data which is being sorted. And when I say sorted, it's mostly in the ascending order. So it's very much useful when we talk about the rank data. So when I say ranked data, it can be considered as the grades which is being received by the students, or you can think of the income. You can also think about the ratings which is being given by the users on a certain product. So these there it's very useful to use the median as the measurement, or this type of data is also called as the ordinal data. So it's very useful for the ranked data. So formula is when n is odd, when the total number of records in the data is odd. So n plus 1 divided by 2 will value will be called as the median. But when n is even, so the average of n by 2 and n by 2 plus 1 term is going to give us the median. So we can see first example. So in this example, we have total 5 records, which means n is equal to n is equal to 5. So what will be as per the formula, the middle value will be 25. So you can see n by 2, you can do n plus 1 divided by 2. So n plus 1 is equal to 5 plus 1, 6 divided by 2 is going to give us the 3. So the median value will be 42. So please remember that this data is not sorted. So first we have to sort the particular data. So we sorted the data here: 25, 30, 42, 80, and 97. And then we calculated the median. So this is the median, the middle value. Okay. Similar way, when we have this is the data we have, but here the number of data is 6, which is an even number. So first we are going to sort them in the ascending order: 1, 2, 3, 4, 5, 6. So we have sorted them in the ascending order, and then what we are going to do, we are going to take the average of 33 and 41, the term which is on the middle term. So the middle term here is being calculated by n by 2. So n by 2 is basically total 6. 6 divided by 2 is equal to 3. So third term is 33. So 33 is being used, plus the n plus 1 divided by 2. So n plus 1 here is so n divided by 2 plus 1. So n divided by 2 is going to be 3. 3 plus 1 is equal to 4. So the fourth term is 41. So 33 plus 41 divided by 2 is going to give us 37. So 37 is the median here. So this is how we calculate median, irrespective of whether the number of records is even or one number of records are odd. So please consider to keep this in mind, that we have to always use the formula based upon the number of records, whether it's even or odd. And also we have to put the data in an order. Now comes the mode. So when we talk about mode, it's the most occurring values. It's basically used when the with the categorical data. We find it out the count of the values. Sometimes in when we are using any analysis, we use the value count method, or in SQL also. So let's say we have these many female, male, and data for the gender. So here the male is equal to 3 and female is equal to 2. So mode will be the male, because male has maximum frequency of occurrence. So, and the good thing about the mode is that it is resistance to outlier. So, because it's mostly used with the categorical data, we can also think about something like number of hours worked by in a factory. So let's say one worker works for six workers work on 8 hours, two workers work on 3 hours, 10 workers working for 5 hours. So then we can say that, okay, since the count of 5 hours is more, 10 workers are working on only 5 hours. So 10 will be mode here. So that's how we can calculate the mode, and it's very useful in finding out the most occurring value in a particular categorical data. Now, then when we're talking about the central measure of central tendency, it's always important to understand that the data is a normally distributed data, or it has a some kind of a skewness. So normally distributed data is something like which is a perfectly bell-shaped curve. You can see this side also and this side also is the same. It's a perfect, and here the mean is equal to median. So when a data is normally distributed data, we can use either mean or median as a measurement, or as a measurement for summarization purpose. But when we talk about left skewed data, so left skewed data is basically, it's a type of data distribution where tail on the left side is much longer or stretched out as compared to the right side. You can see here the left side is more done. This left skewed data is also called as the negatively skewed data. So what happens here is that the mean is usually less than the median, because the extreme values are on the lower end. You see here the extreme values are on the lower end. So that's what happened when you average out. So the mean becomes lower as compared to the median. Okay, it pulls the mean downwards towards this side, towards the left side. So in this case, mean is always less than median. So there are also, we can say that few lower values or outlier values which are on the negative side or more towards the left side, which causes the skewness. So it's a kind of a left skewed data. So these are the values that are stretch that these outlier values are the values which stretch the tail and create the left tail. So always remember, when you have a left skewed data, or whenever there is a skewness in data, you always prefer the of measurement for summarization purpose. Please use median as a because median is never affected by the skewness of the data. It always going to be in the middle. Similar way, when we talk about right skewed data, which is also called as the positively skewed data, it is a type of distribution where the tail is on the much tail is on the right side. You can see here the right side is much more high, which means that the extreme values are on the right side, or the outliers are more towards the right side. What happens when the extreme values are more on the positive side? It's going to make your mean or average much more higher. So that's why what happens here is the mean is greater than the median. So, and in similar way, in this situation also, please use the median as a measurement of summarization, because mean is affected by the skewness of the data, which is caused by the extreme values, or we can also say outliers. Now, this was about a little bit. Let's have a quick think like what are the different types of data on which the measurements can be used. So whenever you are having a nominal data or categorical data, let's say your data has a columns called as gender, nationality, or labels. So in that situation, we use mode as a summarization purpose. Then when you have ordinal data, so when I say ordinal data, it can be grades, it can be income, it can be ratings given by the customers. So then in that situation, we are going to use the median. When you have the numerical data, so we have seen earlier, when it's not skewed, then you can use the mean. In case of normal distributed data where mean is equal to median, so mean can also be considered as a as a measurement purpose or for summarization purpose. But when you have a skewed data, it can be a positively skewed data or a negatively skewed data. So in that case, what happens is like the median is can be considered as the measurement for summarization. Similar way, The what is the significance of central tendency is that it helps us in summarization of the data. So it's also a part of the so when I say summarization, it's also a part of the descriptive statistics, where if we find it out, the mean median mode of the particular data. It helps us in understanding the nature of the data, because in the real world the data is really very huge. Then second thing is the comparison. When I say comparison, let's say I'm working on a project called as demand forecasting, and there we have two inventories, and if we want to compare the average or mean of demand in one inventory and the mean of demand in another inventory, so we can get an idea about where how much is the data, so we can do a kind of comparison also. It helps us in understanding the skewness in the data or handling the skewed data. Okay, so we know that, okay, when we have calculated mean or median, so based upon the comparison between mean and median, we can say that whether the data is skewed or whether it's a normally distributed data. So it can help us in understanding the skewness of the data also. Um, then we can also think about outlier detection. So let's say for some of the products demand is very much higher. Okay, so we can find it has a much more higher value as compared to the normal demands of other products. So in that case, we can find it out. Okay, these values are much more on the higher side. What is the reason behind it? So when we detect the outlier, we can go through all the business implications. That what is the reason behind it? Is it really these outliers are a data quality issue, or it is really happening because of um, certain seasonal changes or any kind of a business impact? Okay, so then we have the benchmarking. We can, when I say, then when we are using a regression problem, so predicting a mean value can also be used as a baseline. So we can say that overall, uh, the measure of central tendency helps us in summarization and better interpretation of data, and it's one of the crucial part of the descriptive statistics. So this was all about measure of central tendency. Thanks.